Okay, kiddos, today we are going to be looking at the law of sines. Today will be a piece of cake. Today we're just going to be looking at what you did in geometry with the law of sines, and then also I'll show you a new area formula. So we use the law of sines when we get stuck because we've solved right triangles. But let's say that the triangle does not have a right angle. In that case, we can't use the regular sine, cosine, and tangent, you know, the opposite, adjacent, hypotenuse thing that we were talking about, because in a non-right triangle, there's not a hypotenuse. So when we know two angles and a side, or two sides and an angle opposite one of those sides, what we can do to solve is use the law of sines instead. So here's the law of sines, and you can use this for when you have triangles where you know an angle, another angle, and then the next side, angle, the side between, and another angle, and when you have this side-side angle case, which we'll talk more about that at the next lesson. So anyway, when you have this triangle ABC, again, it can be any triangle. It doesn't have to be a right triangle. This is our law of sines. We know that we can take the side length over the sine of the opposite angle as a ratio, and that can be true for every single side length and the sine of the angle opposite that side. So basically, each ratio, when you look at it, each ratio is the side length. That's what we use in our numerator. I'm just trying to match the book in case y'all are looking there. Over the sine of the angle opposite that side. Okay? So if you know the side length and the angle opposite that side, that's going to be our base ratio when we use this law of sines. Okay? So we're going to be solving for these triangles, and today we're just going to be focusing on when we know two angles and a side. So in this case here, in example 1a, we know the measure of angle B, and we know the measure of angle C, and we know the side length of B. You could draw a picture if you wanted, but just for time's sake, we won't do that. The thing is that if we know two of the three angles in a triangle, how could we find the other side? Or sorry, just kidding, the other angle? Well, obviously we know, just like we had with the other triangles, that all triangles sum to 180 degrees. So what we can do is we can subtract the 100 degrees and 34 degrees from 180 degrees, and that can find the measure of angle A that we're missing. So if we do that, we find that the measure of angle A is going to be 46 degrees, and so that's one of our pieces. So I believe in most of the problems, you're given the two angles, and then again, to get the third angle, you can just use the triangle sum theorem. So remember that those sum to 180. So now that we have that piece, we have to use the law of sines to get some side lengths. So let's look. We said that we look at a side length, and we have to know the angle opposite that side. So we look at our problem and we see, okay, how can I, what side length and angle opposite that do I know? Well, notice that you have side length B, and you know that the measure of angle B, that's going to be the ratio that you're going to be using. So our base ratio is going to be 8 over the sine of 34 degrees, and we can use that to find our other pieces. So let's go alphabetical. Let's find A first. We need to find side length A, and so then we'll use the sine of angle A in the denominator, which would be the sine of 46 degrees. So we set these two ratios equal to each other. This is a proportion. We know we can solve that by cross multiplying. So if I multiply these two together, I end up with A times the sine of 34 degrees. Multiplying these two together, I get 8 times the sine of 46 degrees. And remember, when you cross multiply in a proportion, you set those cross products equal to each other. I'm not going to put any of this in the calculator yet. I'm going to isolate A, then I'm going to put all this stuff in the calculator. So you can see that we would divide by the sine of 34, and so we end up seeing that A is going to be 8 times the sine of 46 degrees divided by the sine of 34 degrees. So don't put stuff in the calculator and use the decimals. Use the idea that the calculator is going to help you with the order of operations. So let's make sure that my calculator is in degree mode. Okay, that's nice. And then let's just put all this in. We're going to take 8 times the sine of 46 degrees. We only want it to take the sine of 46 degrees, so please make sure to close your parentheses. And then we'll divide that by the sine of 34. And let's round to the nearest tenth, and that gives me about 10.3. So I know that my side A is about 10.3. Now, some of you guys like to use the Pythagorean theorem. Why can we not use the Pythagorean theorem to find the other side of the triangle? That's right, it's because this is not a right triangle. So we have to, once again, use the law of sines. So again, don't use that rounded answer that you got, because if you proceed with a rounded answer, then your other answers are probably not going to be that great. So keep these exact values that we know. We know 8 over the sine of 34 is a very precise ratio we can use. And so then to find side C, we would then take C over the sine of 100 degrees, since that's the measure of angle C. And again, we can cross multiply. So I'd end up with C times the sine of 34 degrees equals 8 times the sine of 100 degrees. And then if I isolate C, I can tell I would have 8 over the sine of 100 degrees over the sine of 34 degrees. And again, I can put that in my calculator. Again, just put in 8 times the sine of 100, close parentheses, divide it by the sine of 34. And here, if I'm rounding to the nearest tenth, that would round to about 14.1 for C. And so now I found the 3 missing pieces in that triangle. So that's the gist of it. And again, your geometry teachers told me that you've done this before, so hopefully this will be a really nice, easy lesson for you. All right, let's try to do letter B together. Notice that we know the measure of angle A and angle B here. And so we might be upset because we're like, oh no, we know side C, but we don't know angle C. But fortunately, because we know 2 of the angles, we can find the third angle by using the triangle sum theorem. So we'll subtract, we'll take 180 minus 51 minus 44 degrees, and that gives me the measure of angle C. So the measure of angle C is 85 degrees. And then I know side C and angle C exactly, so that's what I'll be using in my ratio. So I'll take side C, which is 11, over the sine of angle C, which is 85 degrees. And then I'll find side A first, so I'll take A over the sine of 51 degrees. We're then going to cross multiply. And once you do a lot of these, you kind of see what's going to happen. You're going to multiply the 11 and the sine of 51 degrees, and you're going to divide by the sine of 85 degrees. So that's kind of nice to see what A is when it's isolated. So you don't need to show this interim step that I did in example 1A. So then again, I can just put that whole thing in the calculator. Hopefully y'all trust me, and I'm getting 8.6 for my side A. So now to get side B, I'm again going to use that exact ratio that I know, 11 over the sine of 85. I'll put that equal to B over the sine of 44 degrees. So then thinking about what would happen when I cross multiply and isolate B, I would be multiplying 11 by the sine of 44 degrees and then dividing by the sine of 85 degrees. And if you put that in the calculator, that would give you about 7.7 if we're rounding to the nearest tenth. Okay, so take a second and try this U-try problem. So if you're watching, please pause this video and let's take a minute and try the U-try problem. Okay, here is the finished product. The measure of angle B should be 19 degrees. Now that I know angle B and side B, I can set up a ratio with the side of B, which is 25, over the sine of angle B, which is 19 degrees, so the sine of 19 degrees. And I can set that up and find that A is 76.6 and C is 70.7. Okay? So again, if you need to look at these, all these are on the website for you guys to look at too if you need to double check any of the work there. Alrighty? Before we get to this area of a triangle, I want y'all to flip to the back. And this one is a little bit different. So notice that in this case, they give us 3 pieces, but notice they give us only one angle, 2 sides and 1 angle. So what could we do? Well, let's set up what we have, because we do know that we do have a side and an angle opposite that side. And so we'll take 25 over the sine of 104 degrees. And then we'll take 18, and this time we're looking for the angle. Now don't just put C, remember we're always taking the sine of the angle. Well, let's cross multiply. This looks a little bit different, so I'll show the steps here. So this is going to be 25 times the sine of angle C equals 18 times the sine of 104 degrees. So that means that the sine of C is going to be 18 times the sine of 104 degrees over 25. So remember, we can't divide by sine. That's like not a thing, okay? So to find what the angle is, what do we use? And I know all of you said, use the inverse sign, Miss Lang. You're so right. So to find the measure of angle C, what we're really doing is we're going to be taking the inverse sign of each side. And the inverse sign and the sine cancel, so we're just left with the measure of angle C. And so to find it, we'll take the inverse sine of 18 times the sine of 104 degrees over 25. So let's put that in our calculator. So we can just put that in. So we'll say inverse sine. So we'll say, remember we do the second sine to get to the inverse sine. So inverse sine of 18 times the sine of 104, close that parentheses, divided by 25, close that parentheses, and we get 44.3. And remember, this is an angle that we're finding, which means that we need to put the little degree unit, because if we don't see degrees, that's radians, and 44.3 radians is way different, okay? So now that we have the angle, well, now that we have 2 angles, we can find the third angle. So we can use the triangle sum theorem. We can take 180 minus 104 minus 44.3. So we find that the measure of angle A, I'm going to put is about 31.7 degrees. I should have put about here too. I'm a bad math student today, guys. Sorry. Okay. So whenever you're rounding, put that approximately equal to, okay, so that you're acknowledging that there's some error that could exist, all right? So now we have that the measure of angle A is 31.7 degrees. And now that's enough information for us to find the length of side A. Again, I'm going to use the ones that we were really confident about, the side length of B and angle B. And then I can use that A over the sine of 31.7 degrees. And then I can cross multiply and go from there. So just we'll end up seeing that we get 25 times the sine of 31.7 degrees over the sine of 104 degrees. And if you put that in the calculator, you end up getting about 13.5, okay? In the next lesson, we'll talk about how we want to be careful when we have these cases, but all the ones you'll have in your homework tonight should work out really nicely for you, okay? All right, so those are some of the problems you'll be dealing with. The other problems that you'll be dealing with are some area problems. Now we know that we want to take, we usually take 1/2 base times height, but what if you don't know the perpendicular base and height? What we can do is we can take 1/2 the product of the lengths of 2 sides times the sine of their included angle. Now it looks like there are 3 different formulas for you to memorize. There really aren't. Here's really what this formula is about. Your area is 1/2 one side times another side times the sine of the included angle. Now, included angle means that that's the angle formed like by those 2 sides, okay? So I'll show that to you here. Okay. But this is basically the formula. I wouldn't worry about the A, B, and C stuff. I would just really think about it like this. It's 1/2 side times the sine of the included angle, and you'll be all set. So in example 5, this says you are setting up a triangular flower garden in your backyard. You lay off lengths of 15 feet and 11 feet for two sides of the garden with a 62 angle between these two sides. What will be the area of the garden? Oh, good. It says that the angle is between the two sides. So that means that we can use this formula. So all we do is we take 1/2. The two sides are 15 and 11. And then it says that the angle between them, this pencil's not cooperating, the angle between them is 62 degrees. So we're just going to take 1/2 times 15 times 11 times the sine of 62 degrees. It's that simple, kids. All right, so we can take 1/2. A lot of you guys like to just punch in 0.5. That's fine. Times 15 times 11 times the regular sine of 62. And we end up getting about 72.8. So that's our area. Our area is going to be about 72.8. Let's not forget units. It was measured in feet, and we know that area is measured in square units, so our area would be 72.8 square feet. Now, why don't you guys try this next one here? Remember, just think 1/2 side times the sine of the included angle. So let's pause the video real quick, and you guys try this on your own. Okay, so I ended up getting 1.6 square miles. I just took 1/2. The two sides that like formed the angle were 1.4 and 2.3. The angle they were forming was 78.1. I just put those in the formula, and I get 1.6 square miles. As far as work that you will need to show, I definitely want to see for these law of sines problems, I want to see the ratio, like the proportion. I want to see the A that's isolated, and then what you get in the calculator, okay? So again, proportion, the isolation of A, and then what you get in the calculator. Here, I don't need to see the subtraction from the 180, but I do need to see the final answer, okay? And in these area problems, I need to see the setup and your final answer, okay? Hopefully that's clear. Hopefully this was a nice lesson for you guys, and it will be easy for you to start this homework after the quiz. Of course, this is not on your quiz, but you can do the work afterwards, okay? Have a good day, you guys. Have a good one. Bye.